We're on to our third example using this chocolate scenario. In this one, we're going to talk about how to find the probability between two values. Let me reiterate the scenario one more time. So we're talking about the average number of calories in a 1.5-ounce chocolate bar, which is about 210 calories. We're assuming that the distribution of calories is approximately normal with a standard deviation of 10 calories. Here's problem number 3. Find the probability that a randomly selected chocolate bar will have somewhere between 200 and 220 calories. Now, there are a couple of different ways to do this. Let me show you the shortcut way first, and then I'll show you the longer way second, because the shortcut way you've actually already seen. And I want to tie it into that first so that when we do the longer method, you can see how it ties in quite nicely. All right, so first of all, down at the bottom, you can see the graph showing what we're looking at. Here's the normal distribution with an average of 10 and a standard deviation of 10, average of 210 with a standard deviation of 10. And then I've shaded in the area between 200 and 220. That's the area or the probability that we are looking for. All right, so to picture this, to try and get a good grasp of how to do this the shortcut method, I'm going to draw, first of all, a number line with an average at 210. And then I'm going to draw one standard deviation out, one standard deviation being 10. So that would be 10 in either direction. So that would be 200 to 220. And then another standard deviation out. So another 10 out. That would be 190 to 230. Okay. What area do we want? We want 200 to 220. So that's one standard deviation in either direction. So we want to know what's the probability of being, well, one standard deviation either direction. I hope by saying it that way, I've started ringing some bells. What's the probability of being within one standard deviation in either direction? Okay. If that hasn't rung any bells, maybe pause the video and go back to lesson 7 when we talked about measures of spread, when we started talking about standard deviation, z-scores, and one other thing we talked about right after z-scores. If that hasn't rung any bells yet, let me mention it this way. So basically what we want is, what's the area between plus or minus one standard deviation, right? 200 is one standard deviation below the mean. 220 is one standard deviation above the mean. So what's the area between? And remember how I emphasize so many times that area equals probability. What's the area between plus or minus one standard deviation? So what's the probability within one standard deviation? Well, hopefully you've seen this. If you haven't figured it out yet, take a pause. Go back to lesson 7. See if you can figure that out. Okay, here we go. Ready? That area, as we talked about back in lesson 7, is 68%. This has to do with the empirical rule. Okay? So what's the probability of randomly selecting a chocolate bar that's between 200 and 220 calories? It's going to be 68%. Don't believe me? That's fine. I'm going to show it to you right now. Let's do it. Let's go to the more difficult method. All right, here we go. So I've moved my graph down to the bottom left so that I can work on the right side. So my mean is 210, standard deviation is 10. Now, since I'm not dealing with one of the tails, I'm going to deal with two values. I'm going to need to know the z-score for both of my values. I'm going to say that the value on the left, that's 200, I'm going to call that A. So A is equal to 200, and I need its z-score, so I'm going to put in my value of 200 excuse me, again. And I'm going to find its z-score. 200 minus 210 is negative 10. And that's going to give me a z-score of negative 1. Makes sense because 200 is one standard deviation to the left. And then 220, I'm going to call that b. And zb will be the z-score for that value. That's going to give me a value of positive 1. Again, makes sense because that's one standard deviation to the right. So I'm going to find the probability of being between 200 and 210. In other words, the probability of being between a z-score of plus or minus 1. And then I need to find the probabilities of being less than those two z-scores. So what's the probability, first of all, of being less than a z-score of 1? Well, I look on my z-score chart and my z-table, and I find that the probability of being less than 1 is 0.8413. Okay. Now, I'm not done because that will take the value of 220, and that'll be anything less than that, including everything in the tail. That's everything through the tail. But I don't want that tail. I don't want that. So what do I have to do? Well, let's find the value of that tail as well. Well, what's the probability of a z-score less than negative 1? Again, I look that up on the z-table, and I find that's 0.1587 on the z-table. And that's going to be just my value of 200, or a z-score of negative 1. And that'll just be the left tail. So I'm going to take that big, large area I found first, and I'm going to subtract out that left tail. So I just take that difference, and that difference is going to give me whatever is left. That's going to be what's in the middle. So the probability of being of having a z-score between plus or minus 1 is going to be everything less than positive 1, subtracting out just whatever is less than negative 1. And that gives me a difference of 0.6826, or 68%. And if we go back, didn't we say that's what it was from the empirical rule, 68%? It's exactly what we said it was. And so there we go. We got it from actually doing it the long way, that it's 68%. Now, if you go back and remember, I told you when we did it with when we talked about the empirical rule back in lesson 7, I said it's about 68%. It's not exact, but it's about 68%. Well, here you go. It's the rounded number is 68.26%. This isn't exact either. It's still rounded, but you've got a little more of an exact number. So now you know where those numbers come from. It comes from this exact process. There you go. So now you've had 3 examples where we find the area to the left of a z-score, area to the right of a z-score, and the area between 2 z-scores. In the next couple of examples, we're going to say, well, what if we have the area and we want to find the z-score of that area? And this is actually a pretty common problem as well. So that's what we're going to address in the next couple of videos.